Hey everyone, and welcome to another deep dive. We're tackling a question we hear a lot, and that's, do I really need to be a math whiz to be a software engineer? Good news. The answer is not really. And we're going to break it all down for you today. We're diving into this article called, Do You Need Math to Be a Software Engineer? Debunking the Myth. Just the title alone had us intrigued.
Yeah, it's a common misconception, like this big scary hurdle.
Totally. So let's get right into it. The article jumps right in, saying you don't have to be some kind of math genius to be good at coding.
Which is something I think a lot of people need to hear, because seriously, the number of people who think they could never code because they didn't ace calculus is, well, it's a shame, really.
For sure. It's like saying you can't be a writer if you don't know every grammar rule. But that said, there's definitely some math involved in software engineering, right?
Right, there is. It'd be tough to do anything in this field without some math.
Okay, so what's the deal then? How much math are we really talking here?
Well, the article actually lays out what they call the 20% rule, which I thought was interesting.
The 20% rule. Okay, tell me more.
Basically, it says that for, the vast majority of software engineering jobs, you really only need to know the math you learned by, say, 6th, 7th, 8th grade.
Really? Just that?
That's what they're saying. The core concepts are what matters most. Addition, subtraction, that kind of thing.
Okay, so nothing too crazy. You don't need to be deriving equations or anything.
Not unless you want to, of course. But for most day-to-day programming, it's about understanding the basics and how to use them.
Makes sense. So we're talking basic arithmetic. What else?
Some basic algebra helps, and then logic comes in super important in programming.
Oh, yeah, that makes sense. Computers think in logic.
Exactly. And specifically, there's something called Boolean logic, which sounds way more complicated than it is. It's basically just about true or false, yes or no. It's how we make decisions all the time, and it's how computers make decisions, too.
Ah, okay. So it's like, is this light switch on? Yes or no? Is this variable equal to 5? True or false?
Exactly. It's about those clear, logical conditions. And then a little bit of statistics can come in handy, depending on what you're working on.
Got it. So like if you're working with data or something like that?
Right. But again, even then, we're not talking about needing some crazy advanced degree in statistics. It's more about the foundational concepts.
Okay, so we've established that you don't need to be a math whiz to code. That's a relief for some people, I'm sure. But the article goes deeper than just the types of math, right?
But it goes deeper.
Yeah. The article makes this point. It's not even really about the actual math. It's more about how math trains your brain. Like they have this quote. Hold on, let me pull it up here. Okay, yeah, here it is. Math is an amazing thing. Yeah. My experience with math was that it also involves problem solving, right? Like programming, like coding interviews, and solving all those problems. Develop my thinking process and help me use some tools together in order to solve the problem.
Totally, and that's what's so key.
It's like that saying, give a man a fish he eats for a day. Teach a man to fish.
He eats for a lifetime.
Yeah.
It's not about memorizing formulas. It's about developing that problem-solving mindset.
Okay, so then what does mathematical thinking even mean when we're talking about software engineering?
So it's like, imagine you have this big, hairy coding problem. It can feel overwhelming, right?
Definitely. Where do you even start?
Right, exactly. Mathematical thinking helps you break that problem down into smaller, bite-sized pieces that you can actually tackle. It's about looking for patterns, thinking logically, and then applying the right tools to solve each piece of the puzzle.
So like you're taking this big abstract problem and making it more concrete, more manageable.
Exactly. It's about creating a roadmap for yourself, a step-by-step plan to reach a solution.
So we've covered the basics and we've talked about the problem-solving aspect. But what about our listeners who are math whizzes, the ones who actually enjoy the challenge of advanced math? What does the article say to them?
Oh, it definitely doesn't leave them out. In fact, it highlights some seriously cool areas where that advanced math knowledge can really shine. Computer graphics, for example.
Like in video games and animation, those incredible visuals.
Exactly. Think about how lifelike those characters and landscapes look. There's a ton of math going on behind the scenes to create those images.
Okay, so walk us through it. What kind of math are we talking about?
Well, linear algebra is huge in computer graphics. It helps you manipulate objects in 3D space, make them move and rotate realistically. And then you've got trigonometry for calculating angles and distances. And even some calculus can come into play when you're trying to create those smooth curves and animations.
Wow, it's amazing to think that all those abstract mathematical concepts translate into something we can actually see and experience on screen.
It really is. And that's just one example. Artificial intelligence, or AI, is another area where advanced math is crucial.
AI is such a hot topic right now. I mean, it seems like AI is popping up everywhere these days.
And for good reason. It's a rapidly growing field, and it relies heavily on math, especially probability and statistics.
So how does that work?
Basically, you're using math to teach machines how to learn from data. It's about recognizing patterns in that data and then using those patterns to make predictions. It's like you're building a brain that can get smarter over time.
It's credible, really, how far math can take us. But I'm sure some of our listeners are probably feeling a little overwhelmed right now. I mean, we've talked about everything from basic arithmetic to AI. It's a lot to process. Yeah, if you're just starting out, it can feel like there's so much to learn.
It's true, but the article emphasizes this idea of a growth mindset. You don't have to be a math expert on day one, you know? It's all about starting with the fundamentals and building from there. It's a journey, not like a sprint to the finish line or something.
Right, it's about progress, not perfection.
Exactly. And the cool thing is that there are tons of practical ways you can strengthen those mathematical thinking muscles.
Okay, so give us the actionable steps here. What can our listeners do to kind of sharpen those skills?
Well, the article mentions trying out logic puzzles, things like Sudoku.
Oh, yeah, those are fun.
Right, or even just those brain teaser games you find online. They're like everywhere. They're actually really good for getting you to think strategically, break a problem down into steps, that kind of thing.
It's like a workout for your brain.
Totally. And then the article mentions something called discrete math.
Discrete math. Okay. Now, that sounds a little intimidating. I'm not going to lie.
I know, it sounds like something out of, like, a super advanced physics class or something, but it's actually not as scary as it sounds. Promise. So, discrete math deals with distinct, separate values. Kind of like, think about the ones and easers that computers use.
Binary code.
Right, exactly. So, understanding discrete math can actually make you a way more efficient coder because you're, like, starting to think the way a computer thinks.
Ah, so you're bridging that gap between human logic and computer logic.
Exactly. And of course, nothing beats just diving in and getting your hands dirty with some actual code. Challenge yourself with coding exercises, work on personal projects, like whatever interests you. And don't be afraid to totally mess up and make a ton of mistakes. That's how you learn, right?
Absolutely. Mistakes are just learning opportunities in disguise.
That's a great way to put it.
So it sounds like the main takeaway here is that math is a tool, not a barrier to entry when it comes to software engineering.
100%. It's a tool in your toolkit, like one of many. You don't need to be like this math genius, but understanding the basic principles and really honing that problem-solving mindset, that's going to take you super far in this field.
I love that. So inspiring. This has been a really fascinating deep dive. Thanks so much for breaking it all down for us.
Anytime. Glad to be here.
To all our listeners out there, remember, a career in tech is within your reach. Don't let that math myth hold you back. Thanks for tuning in to another deep dive. We'll see you next time.